This is going to be example number 8, which we didn't get to in class, but it's not too bad, and it's pretty straightforward on how to manipulate the Maclaurin polynomials. So in example 8, you want to list the first 4 non-zero terms of the Maclaurin polynomials for f of x equals sine x, f of x equals cosine x, and f of x equals e to the x. And then we're going to find the following Maclaurin polynomials, so we're going to manipulate them. So let's start with the first part of this. So for f of x equals sine x, we're going to write the first 4 non-zero terms of that. So sine x is approximately equal to the first 4 non-zeros, remember? So we start with our process x minus, the first one would have been a 0, right? The second one, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And again, this was one that we had done earlier in one of our previous examples. So this might be one that you want to memorize. It's pretty straightforward. It's the odd term. So x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. If not, you can go through that process where you do f of 0 equals sine of 0 equals 1, and then go through that whole process. You know, f prime, that's going to be cosine of x, cosine of 0, and then again, go through that whole process. F of x equals cosine x. Now, we haven't done this one, right? But this is going to be pretty straightforward. What's cosine x? Well, cosine x is the derivative of sine x. So let's just take our terms and we'll take the derivative of this. So what's the derivative of x? That's going to be 1. What's the derivative of x cubed? That's 3x squared, right? So this one's going to be minus 3x squared over 3 factorial. What's the derivative of x to the 5th? 5x to the 4th over 5 factorial minus, what's the derivative of x to the 7th? 7x to the 6th over 7 factorial. Well, we can rewrite this, right? We can clean this up just a little bit. And so what do we get? 1 minus, like we talked about in class, 3 factorial is 3 times 2 times 1. So 3x squared over 3 times 2 times 1. This is going to be 3. This is going to be x squared over 2 factorial plus 5x to the 4th over 5 factorial. Again, 5 times 4 times 3 times 2 times 1. The 5s will cancel each other out, so you're left with x to the 4th over 4 factorial. And again, 7x to the 6th over 7 factorial. We're left with x to the 6th over 6 factorial. Okay, so again, sine x, you've got x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Cosine is just that derivative of it. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And then what was the last one they wanted us to do was e to the x. Okay, so e to the x. And again, this was one that we happened to do before. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay, so now they want to take these bits and we're going to do this to it, right? We're gonna make some adjustments to them. So let's start with the first one. G of x equals sine 2x. So if we take the sine 2x, here we go. Sine 2x. If we take what we had, which is sine of x is approximately x minus the x cubed over 3 factorial, this first little bit, and we multiply the x's by 2x, we could substitute in. So we get sine of 2x is approximately equal to, And basically what we're going to do is anywhere we have an x, we're going to make it a 2x. So we get 2x minus 2x cubed over 3 factorial plus 2x to the 5th over 5 factorial minus 2x. Rewrite that. 2x to the 7th over 7 factorial. Now you can leave it in this format, or if you wanted to, we can clean this up just a tiny little bit. 2x cubed, this is 8x over 3 factorial plus, this would be 32x to the 5th, my cubed, over 5 factorial minus, this is 128x to the 7th over 7 factorial. Okay, so again, all we did was we substituted out anywhere we had an x, we made it a 2x. Okay, so let's look at what was the next one. G of x equals x times the cosine of x. Let's make that a little bit better. X cosine of x. Okay, so cosine of x is approximately equal to 1 minus, we had an x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And now what we're going to do is, to get from cosine x to x cosine x, we multiply by an x. So we're going to do that here, and what do we get? We get x minus x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial. And that's all that it is. Okay, now let's take a look at the last one. We've got g of x equals 4e to the x squared. So g of x equals 4e to the x squared. So let's start with our original form, which is e to the x. It's approximately 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So the first thing I want to do, at least with this one, is I'm going to replace all of my x's with x squareds. So e to the x squared is equal to 1 plus x squared plus, now remember, x squared squared, that's going to be x to the 4th over 2 factorial plus x cubed squared. Remember your rules for exponents. This is going to be x to the 6th over 3 factorial. And now, to get this to the next step, this is going to be 4 times e x squared. So I'm going to multiply by 4. 4 plus 4x squared plus 4x to the 4th over 2 factorial plus 4x to the 6th over 3 factorial. And you can reduce this just a little bit if you wanted to. 4 plus 4x squared plus 4x to the 4th over 2 factorial. This just reduces down to 2x to the 4th. Plus, and we could take, there's a 2 in here, right? 3 times 2 times 1, so there's a 2 in here, so this is just 2x to the 6th over 3. That's all that remains. And there you go. So we've taken this from g of x, from e to the x to 4e to the x squared. And that's all there is to it. It's really not too bad. Let me know if you have any questions.